Hello guys, welcome to Self-Help Maths Academy. In today's discussion, I'm going to talk about the LU decomposition method. It's also called as Cholesky's method. So here in this method, what we try to do is, we will try to consider a system of equations in the form of ax equal to b, and then we will try to find out the value of unknowns, that is x. Okay, so here in this method what we do is we try to reduce the given system of equation into ax equal to b, and that a we will try to write it in terms of a lower and upper triangular matrix. That is, like you see, if I have been given with the ax is equal to b, then this is our system of equation where our a we will write it in terms of L into U, where L is the lower triangular matrix and U is the upper triangular matrix. Okay, so in specifically what we do is, we will try to take either one of them diagonal elements as 1 for our convenience. Okay, so let's start. First let us understand the method. How do we do it? So the diagonal elements of L or U can be unity, depends on the convenience, as I told you. So here, let the coefficient matrix of the given, let the coefficient matrix of the given system A is equal to A11, A12, A13, A21, A22, A23, and A31, A32, A33. So similarly, like you have got, these are nothing but what, the first row first element, first row second element, and first row third column element, like that. So this is second row first column, and second row second column, and second row third column, and so on. Okay, so here we try to write this A in terms of L and U, like how. So here if you see, your given matrix A, which is A11, A12, A13, A21, A22, A23, and A31, A32, A33. So this we are writing in terms of a lower triangular, that is L11, remaining elements are 0, L21, L22 0, L31, L32, L33. Okay, so now this is into the upper triangular, like here in the upper triangular, as I told you, diagonal elements we will take it as 1. This is U12, U2, U13, then this is 0, then you have got the diagonal element as 1, so this is your U23, this is 0, 0, then the diagonal element as 1. Okay, so this is how we write this, our L, and this is our U. Your A is written as L into U. Okay, and then after writing that, we will multiply them. Okay, so we multiply this into this, this into this. Likewise, we will get this particular thing. After multiplication, we get the matrix. Okay, that is the row into the column. Likewise, we will get all these terms. Once we get, then we are going to equate the corresponding elements. Like A11, I'm going to corresponding to the first element, A12 the second element, A13 to the third element. Likewise, we equate the corresponding elements, and we will try to find out the value of the unknowns which are required for L and U. So once we find that, hence your A is equal to LU, your A is equal to LU, then your equation Ax equal to B, that becomes LU times X, that is equal to B. Since your A, this is nothing but your A, this in place of A I am writing here L into U. So since it is it holds the associative property, so I can write this as L of Ux is equal to B. Now what we do is, we'll try to take this Ux as some Y, this U into X as some Y. Okay, so once I take this, then this equation, let me take this as star, then the star equation becomes L Ux is Y, so Ly equal to B. So in this case, your lower triangular is known to you, coefficient is known to you, this is unknown, so you can find out Y easily from here. So these two are known to us. So from this we find out Y. So once we find out y, we go back to this equation and we'll substitute it here. Then it becomes ux is equal to, since y is known to us, so we know y here. Then in this particular case, now you know y from here. You know the upper triangular matrix, so only x is unknown. So it is easy to calculate from here. So this will give you the required x value. That's how we find out the x values by using the LU decomposition method. Now we see one example for this LU decomposition and we will try to understand it thoroughly. Now let us see this particular system of equations. Okay, how do we find out the x1, x2, x3 by using the LU decomposition method? So in this, first let me write the matrices of the form which is given in terms of the systems of equation. So we'll write it in terms of Ax equal to b. So to write in terms of Ax equal to b, now I'll write our A. So A is a coefficient matrix. The coefficients of x1, x2, x3, that is 4, 1, 1, 1, 4, negative 2, and this is 3, 2, negative 4. Okay, this is our A, and x1, x2, x3, these are the unknowns, is equal to your coefficient matrix is 4, 4, 6. This is a coefficient of unknown. This is your unknown matrix, and this is your coefficient on the right hand side. All right. Now let the first step is let your L into U is equal to A. Okay. So assume L and U as following. So I'm going to write, you see, L as your lower triangular matrix, L11, 0, 0, L21, L22, 0, and then L31, L32, L33, and your U is 1, U12, U13. This is 0, 1, U23, 0, 0, 1. This is your upper triangular matrix. This is equal to your A, that is 4, 1, 1, 1, 4, negative 2, 3, 2, negative 4. Okay. So now we have written this in the form of L into U is equal to A. So let's multiply this into this and we will see what we will obtain. Okay. So once we multiply L into U, and we will see what it gives. So this will give us, now I'll try to multiply this with row into column. So we will obtain here, we will get, so after multiplying the row into column, so that is L11 into 1. Okay, then this is 0, so no worry. L11 into U12, L11 into U12, the remaining are 0. L11 into U13, the remaining are 0. Similarly, second row with first column, L21, then L21, U12 plus L22, then second row with the third column, L21, U13 plus L22, U23, and then the third row with the third column, we will obtain L31, this is L31 into U12 plus L32, and this is L31 U13 plus L32 U23 plus L33. So this is the multiplication of upper and lower triangular matrix. This is equal to, I'll write now, that is equal to 4, 1, 1, then 1, 4, negative 2. We have got 3, 2, negative 4. Okay. So this is the resultant matrix we have got. Now what we do is we try to equate the corresponding the elements. We try to equate the corresponding elements here. Then what we do, we get here L11 equal to say 4, and L11 U12 equal to 1. Corresponding columns into corresponding columns here. Then we got L21 equal to 1. Then L21 U12 plus L22 is equal to 4. Then L31 equal to 3. L31 U12 plus L32 equal to 2. So this is it. Let me take this as 1. Then we have got L11 U13 is 1. L21 U13 plus L22 U23 is negative 2. Then L31 U13 L32 U23 plus L33 equal to negative 4. This is our question 2. Now what we do is, we have got, there are two systems which we need to solve. Okay, so what I take is, we take L11 here. We have got the L11 value. So we are going to substitute in this. So we can find out U12 from here. And once we find out U12 from this, L21 is known. We can find out L22. Okay, likewise we can also find out L32. Okay, so let's do it. So from here, in this first system, we know that L11 U12 is 1. This implies your U12 is 1 over L11. That is equal to 1 over 4. So this implies your U12 is 1 over 4. You got the value of U12. So once you get the value of U12, similarly from the system 1, we can find out L22. So let's take that. So from here, we get L21 U12 plus L22 equal to 4. This implies your L22 is 4 minus L21 U12. This is equal to 4 minus, your L21 is known, that is the value is 1 here. We have got the L21 value as 1. U12 we calculated, so let's substitute that. So L21 is 1, U12 is 1 over 4. This is 4 minus 1 by 4. LCM is 4, so this is 16 minus 1 by 4, which is equal to 15 by 4. Hence we have got L22 is 15 by 4. We have got L22 value. Now similarly, from the third equation, we have to find out L32. Okay, so therefore L31 U12 plus L32 is equal to 2. So this implies L32 is 2 minus L31 U12, which is equal to 2 minus, now L31 is 3 from here, and U12 is 1 by 4, that is equal to 2 minus 3 by 4, which is equal to, the LCM is 4, so therefore it is 8 minus 3 by 4, which is equal to 5 by 4. So hence we have got your L32 value as 5 by 4. Now you got, once we got L32, now by considering the system 2, this equation, let us find out the remaining values. So from here you know L11, so we can find out U13 from this. Okay, so let us take, you know that your L11 U13 is equal to 1. So therefore U13 is 1 over L11. So 1 divided by, since L11 is 4, we can substitute the value and we'll get that as 4. Thus we got the value of U13 as 1 over 4. Okay, now we got the value of U13. So similarly, from this system, you have got now U13, you know L21, you also know L22. Okay, because we found the L22 from the system 1. So we can find out now simply U23 from this. So let's consider that system. Okay. Now we have this equation, that is L21 U13 plus L22 U23 is equal to -2. So L21 is known to us. So let's substitute that. L21 is given as 1 and U13, which we have calculated just now, that is 1 by 4, plus L22, that also we have calculated, that is 15 by 4, and your U23, that is equal to -2. So let me consider this. 15 by 4 U23 is equal to -2. So 1 times of 1 by 4 is 1 by 4. Let us take this hand, it is -1 by 4. So this is 15 by 4 U23 is equal to, so like 4 is the LCM, so that will become -9 over 4. That is -9 by 4. So therefore your U23 will be -9 by 4. I'll take 15 over 4 on this side. It becomes 4 over 15. So 4 cancels. 3 times of 3 and 3 times of 5. That is -3 over 5. So this is equal to U23 is equal to -3 by 5. So now you have got U23 is equal to -3 by 5. Okay. So let's find out the, from this equation. Now we have got here, from this we have got U13. From this we have got U23. Now let us find out what is L33. So for this, consider the last equation. That will be L31 U13 plus L32 U23 plus L33 is equal to -4. Okay. So now I'll find out L33, that is equal to -4 minus L31 U13 minus L32 U23. Okay. This is equal to -4 minus L31. L31 is known to us. We has been given as 3. U13 we found, that is 1 by 4. L32 we have found, that is 5 by 4. And U23 just we found, that is -3 by 4. So let's calculate this. So -4, this is 3 times of 3 by 4. So negative into negative, it is positive. Then you can cancel this 5. So this is simply 3 over 4. So here in this case, if you observe, there is a -3 by 4, positive 3 by 4. So therefore simply your L33 will be -4. Okay. So you have got L33 as -4. So clearly we have got all the unknowns now. So hence we are now good to form our required lower triangular and upper triangular matrices. So let's do it now, since we know that all the unknowns which we are trying to find out. So if you want, you can just write it at one place, and we are good to go with them. So let me just quickly write all the unknowns which we have calculated. So we know that L11 is 4 now. L12, sorry, we don't want L12. So this is L21 is 1. Then L31 is 3. Then we have calculated L22, which is 15 by 4. Then L32, which is 5 by 4. And then we have calculated L33, which is equal to -4. Similarly, we have calculated U13, which is 1 by 4, U23, which is -3 by 5, and U12, which is 1 by 4. So these are the unknowns which we have calculated now. So we are now good with all the unknowns. So hence we can substitute them in the system. So now let us consider, okay, let us consider a system AX equal to B. So that is nothing but, as I told you, your A is nothing but LU times of X is equal to B. Okay. Or since multiplication is associative, I can write this as L of UX is equal to B. Okay. So if you take this as say 1, let me take this as say 2, and this as 3. Now I replace this UX. Let UX is equal to some Y. Let me take this as equation 4. and then your equation 3 becomes what? Ly equal to b. Let me take this as equation 5. So these all are like, interconnected. So all the equations, I'm just naming it for our better, like, so when I'm solving it, it will be easy for us to deal with. You can see now, once we have got the value of say after writing the system, we have got the value of y1. Once we got the y1 value as 1, so substituting that in the second equation, I'm just naming it as star, double star and triple star. So after that we are substituting the value of y1 in the double star equation. So after finding this in the double star, you have got the value of y2 as 4 by 5, and once you got y2 value, substitute that in the triple star equation, that is 3y1 plus 5 by 4 y2 and minus 4y3, that is equal to 6. So here, after substituting in this equation, since you know y1 from here, y2 from here, so I will be getting the value of y3. You can see that in the detailed calculations we have done. So substituting the value of y1 and y2. So here 5 and 5 cancels, 4 and 4 cancels. So minus 4y3 equal to 6 I have got. So 3 plus 1 minus 4y3 is equal to 6. So this is negative 4y3 is equal to 6 minus 4. So negative 4y3 is equal to 2. So therefore y3 is equal to what? It is 2 divided by negative 4, which is negative 1 by 2. So therefore I got the value of y3 as negative 1 by 2. Okay. So I've got now from here, I've got y1, I've got y2 and I've got y3. So now we are good with the equations of y1, y2 and y3. Let's calculate now. Let's substitute back that in the given equation. Let's substitute that in the equation which we started with, like ux is equal to y. Okay, so I'll substitute here y values and we will write as follows. So from here, you know that your u is 1 over 4, 1 over 4. So these are the calculated values: 0, 1, negative 3 by 5, 0, 0, 1. And these are unknowns x1, x2, x3, which is equal to you have got here your y1 value, y1, y2, y3 values. So please write them: y1, y2 and y3, that is negative 1 by 2. Okay, so now this is again by the Gauss elimination method. So we just go over the backward substitution. So this is 1 into x3 is equal to negative 1 by 2. Okay, and then this is, here we have got x2 minus 3 by 5 x3 is equal to 4 by 5. And from the first equation, this is simply x1 plus 1 by 4 x2 plus 1 by 4 x3 equal to 1. So now you have got three equations again. So from here it is clear x3 value is negative 1 by 2, that I'm going to substitute in this equation. So from here you can see that x2 minus 3 by 5 x3 is negative 1 by 2, which is equal to 4 by 5. So this will give me x2, negative into negative, it is positive, 3 by 10 equal to 4 by 5. Okay, so this is x2 equal to 4 by 5 minus 3 by 10. So 5 and 10 LCM is 10, so times of 2, which is equal to 4 times of 2, you have got 8 minus 3 by 10, which is equal to 5 by 10, which is nothing but 1 over 2. So you have got here x2 value as 1 over 2. Okay, so we have got the x3 value as negative 1 by 2 and we have got x2 value as 1 by 2. Okay, now let's find out the x1 value. So here, by taking this the final equation, here we have got x1 equal to 1 minus 1 by 4 times of x2 minus 1 by 4 times of x3. This is equal to 1 minus 1 by 4. x2 is negative, sorry, 1 by 2 minus 1 by 4. x3 is negative 1 by 2. So this will give you 1. So this is minus 1 by 8 and this is plus 1 by 8. So we can cancel both negative 1 by 8, positive 1 by 8. So therefore you get x1 value as 1. Okay. So from here it is clear we have got x1 value, we have got x2 value, and we got x3 value. So therefore the final answer for your system of equation is your x1 is 1, x2 is x2 is 1 by 2 and your x3 is negative 1 by 2. So this is how we found the equation, the system of equation, the unknowns for a given system by using the decomposition method. Yeah, it is actually a little lengthy method, but it is quite simple. But if you just understand the steps, the basic steps, that like what we are trying to do here, so then it will be quite easy to solve the examples. So this is all in this particular examples, guys. So maybe in the next video will try to take up some more examples on the next different concept. Okay, till then, take care.